The three primary trig ratios are sine, cosine, and tangent. The sine of an angle is equal to, do you know the ratio? Opposite over hypotenuse. The cosine of an angle is adjacent over hypotenuse. And the tangent of an angle, opposite over adjacent. And you've done a fair bit with these before because you worked with it in grade 10, and then again in grade 11. And in grade 11, we also would have looked at the sine law and the cosine law. So you should be fairly familiar with these. These are the three primary trig ratios. There are also three secondary trig ratios, and those are cosecant, secant, and cotangent. And these are the reciprocals of the primary trig ratios. So cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. And cotangent is the reciprocal of tangent. These aren't used very much, these cosecant, secant, and cotangent. They were really more useful when people didn't have handheld calculators and were doing trigonometry with trig tables. Then those ones were used a fair bit. But now that we have handheld calculators, there's not really a lot of use for them in terms of your basic trig, like finding side lengths, finding angles, that stuff. They're not used. So that's why you, even though you did trig before, you may not have heard of those ones. This is some other information that you need to know. So the special triangles are going to be useful for finding trig ratios of special angles, which are angles that are multiples of pi over 6, pi over 3, or pi over 4. The cast rule as well is one that's good to memorize. The way that it works, these are the x and y axes. So a coordinate system. And we just write the word cast counterclockwise, starting in the fourth quadrant, or some people call it all students take calculus. Doesn't matter, however you want to remember it. I just remember it C-A-S-T. And what it means is that if you have an angle in standard position and you're finding the trig ratio of it, all of those ratios are positive in the first quadrant. In the second quadrant, only sine is positive, and the rest are negative. Sine and its reciprocal. In the third quadrant, only tangent is positive, so that's why it's T for tangent. And in the fourth quadrant, cosine is the one that's positive. Here's the type of thing that we need to be able to do. Find the exact value for each trig ratio. The sine of 2 pi over 3 is the first one. First thing I want to do when I have this question, find the sine of 2 pi over 3, is I want to figure out where is 2 pi over 3 in standard position. So I'm just going to draw a little coordinate system. And I want 2 pi over 3. I know that that's around there, right? If I split this, if I kind of think of splitting the half circle into 3 pieces and taking 2/3, 1/3, 2/3, it puts it over there. So it's in that second quadrant. And then I need to think of what is the reference angle for that. And the reference angle is just the angle in here, which is pi over 3. If this is 1 pi over 3, 2 pi over 3, that's 1 pi over 3 in there. And then I'm going to find the sine of the reference angle. So I want to find the sine of pi over 3. That's pi over 3. And I'm going to do that using the special triangles. So I need that triangle that has a pi over 3 in it. And that was this one. 1, 2, root 3, and the pi over 3 was down here, right? You guys have them written down? But 1, 2, and root 3 are the side lengths, and there's the pi over 3 here, and I just want to find the sine of it. So I need to do opposite over hypotenuse. What's the opposite side? Root 3 and the hypotenuse? 2. So the answer to this is root 3 over 2, opposite over hypotenuse. But it may be positive or it may be negative. We then need to consider that. Which, if we think of the cast rule, and I just go C, A, S, T, it's in the second quadrant where sine is positive, so the answer should be positive, so that's it, I'm done. That's my answer. That's the sine of 2 pi over 3. We'll go through the same process for cosine of 7 pi over 6. Which quadrant is 7 pi over 6 in? The third quadrant, right. Because 6/6 would bring you right to 180, and 1/6 more, so it's like there. With a reference angle of pi over 6. I mean, the reference angle is basically just one of whatever it's made up of. So if this is made up of 7 pi over 6, it's going to be pi over 6. This one was 2 pi over 3. The reference angle is going to be pi over 3. And then, so we're going to use the same triangle, same special triangle as we did in the previous one, except that we're looking at this angle up here, because there's the pi over 6. And we want the cosine of that angle. Cosine is adjacent over hypotenuse, which means it's also root 3 over 2. We then need to consider, should it be positive or should it be negative? And you say negative, and you're right. It's negative because the only thing that's positive in here is tangent, which means the other ones have to be negative. So the cosine of 7 pi over 6 is negative root 3 over 2. The next one that we have there is the cotangent of 11 pi over 3. So the first thing I want you to do is figure out which quadrant is 11 pi over 3 in. 11 pi over 3 is in the fourth quadrant. And what's the reference angle for 11 pi over 3? Pi over 3. So it's in there. The reference angle is pi over 3. So we need to find the cotangent of pi over 3. Trying to find the cotangent of pi over 3. Cotangent, we said, is the reciprocal of tangent. So I'm actually going to start by finding the tangent of pi over 3. And I'll use that same special triangle, this one, that we used in both of those. Pi over 3 is at the bottom. Tangent is opposite over adjacent, root 3 over 1. So the cotangent then is the reciprocal of that, 1 over root 3. Then we just need to decide, is it positive or negative? But if you find, so if you're doing cotangent, find the tangent and then take the reciprocal of it, because they're reciprocal ratios. Should it be positive or negative there? Cosine and its reciprocal are positive in the fourth quadrant, so this must be negative. Secant of 3 pi over 4. Which quadrant is 3 pi over 4 in? Second quadrant, 3/4 of a pi. So it's in there. And for this one, we're using the other special triangle, the 1, 1, root 2, because we want pi over 4 as our reference angle. Secant is the reciprocal of which of the primary ratios? Cosine, yeah. So we'll start by finding the cosine of pi over 4. Cosine of pi over 4, well, cosine is adjacent over hypotenuse, right? So 1 over root 2. So to find the secant of 3 pi over 4, flip that over, it's root 2 over 1, or just root 2. And should it be positive or negative? Negative. Because sine and its reciprocal are the ones that are positive in the second quadrant. When you have a circle like this, and an angle in standard position, this first one in the first quadrant, the angle would be pi over 6, right? In here, pi over 6. The coordinates of the point, like this point right here, the coordinates of that point are actually the cosine of that angle and the sine of that angle. So the cosine of that angle is the x value of that coordinate, and the sine of that angle is the y coordinate. So you're going to find the coordinates of all of those points based on using the special triangles. So really what you're going to do to find this point at pi over 6, you're going to find the cosine of pi over 6 and the sine of pi over 6, and those will be your values that go in there. And then you're going to find the cosine and the sine of the next one, which is pi over 4, and then the cosine and the sine of pi over 3, and continue to fill in this whole thing. Another piece of information that I have here, just for you, because we're going to use it later, is that tangent is actually equal to sine over cosine. Tangent is also opposite over adjacent, but sometimes it's useful to know that the tangent is sine over cosine. So I added that in there as well. And I'm just going to give you some time to start trying to figure this out. So the first thing you're going to do, like I said, is find the cosine of pi over 6. And then find the sine of pi over 6. And that'll give you the coordinates of that point.